Okay, everyone, let's get started. Bang on 11 o'clock. We only have 25 minutes and I have so much to talk to you about. My name's Amy Boyd. I am something called a cloud advocate at Microsoft. I work in developer relations, so I work with developers around data science and AI technologies and kind of do a lot of learning pieces, as well as working with our engineering teams to make our own AI products better. This talk, though, it isn't really about that. This is about this kind of whole other part of AI that I've recently been looking into. This talk is a brief, we only have 25 minutes, and this area is huge, past, present, and future of ethics in AI. I've had a chance to speak to some quite interesting people, and I just really want to share with you some of the things that they've told me. And I understand I've barely scratched the surface of this, so if anyone has been looking at this space or working in this space, do let me know afterwards. I'd love to have a chat. But first, we're actually going to start with this. So this is a bit like, have I got news for you, or something like this. Do we know any of the people up here? Come on, give us a, yeah, anyone? Could you know a name of any of them? Yes, bottom. Yeah, Ryland Clark. Yeah, spot on. Ryland Clark is now a really, really popular member of This Morning team. So if you ever get a chance to watch daytime TV, you'll probably see Ryland quite a lot. Does anyone recognise anyone else on here? Any hands? The middle one, do we recognise him? It's James Arthur, right? So James Arthur is a singer and songwriter, and he's had some number ones. He's kind of been here, and then he's kind of gone, and then he's kind of come back. And some people in my family had one of their first wedding songs. I think was a James Arthur song. And then up here we have a lady, another singer called Ella Henderson. She had some really cool songs. She was on my Spotify playlist at one point. Can anyone tell me what all these people have in common? What did they all do together? X Factor, yes. So X Factor 2012. I am starting to age a little bit. All of these people. So we also have a lady called Lucy Spranigan down here. She was quite quirky. She had a really cool song that she wrote for herself. YouTube all these people afterwards. And then Christopher Meloni up at the top, and we'll talk a bit more about the unfortunate side of social media that he saw. But basically, the X Factor 2012, 2013, 2014, I was in my final year of academia, and I was putting together my thesis. And I was like, well, what is it that I want to do? I'd had a chance to work at Bing, Microsoft search engine, as an intern, and I had this huge passion. It was the takeoff in Twitter. I was suddenly seeing so much usage of Twitter and Facebook, and social media was on the rise. And that was actually even being integrated into search engines and stuff like that, and ranking and stuff like that. So when I went back to university, I was chatting to my supervisor, and I said, okay, I have an idea for you. My whole year's worth of project, I'm going to call it the Twitterati. Does anyone know what the word the Twitterati, or who the Twitterati are? No, it's a strange one. If you Google it, though, it has a genuine definition that just comes up right at the top of the page. The Twitterati are users of Twitter, especially those who post frequently and have a large number of followers. So think your Katy Perrys, your Justin Biebers, Barack Obama, any of the Kardashians, all of that kind of stuff, right? So when they post something, it's so influential. They can post I'm eating toast, and it will get retweeted 300,000 times or something. It's unbelievable. But the Twitterati, I basically called this the Twitterati because I said, hey, the X Factor is as much a music competition as it is a popularity contest. Let's be honest, right? We, as the British public, get a chance to vote and keep these people in, and whether we like the way that they sing, but we also like them, right? They play hard on some of the sub stories, or they play hard on some of the personalities and stuff like that. We have to like people to want to vote for them. And so I called it the Twitterati, and I said, hey, I'm gonna basically, given Twitter data, try and predict the outcome of the X Factor. So I chose 2012. At the time, I think it was 2014, And I really wanted to do that years because Little Mix were in it, and I love Little Mix, like my fave people. But what I needed to do is I needed to learn from past data, obviously using machine learning, to then be able to predict future stuff. So this is where I was going. I was like, right, this is what I'm going to do. I mean, in some senses, I feel sorry for my supervisor because he was probably like, why do I always get the crazy ones? Like, why can't you just do what everyone else is doing? I already stood out, as we all expect, right, in my computer science course, rather a lot with my very blonde hair. But it was very exciting because I was like, no, I love this. I'm going to have to work on this. So I'm going to bring together my personal passion as well as my technical background. So it wasn't trivial. I actually dug this out off one of my external hard drives because I was like, no, I'm going to read through, after I started sort of going into ethics in AI, I'm going to read through my past research. I'm going to see actually because there was a lot of data and there was a lot of questions that I had of the data. But it like, no word of a lie, like wasn't trivial, because it sounds like it's a really trivial subject. I did a lot of research. I used, do we have any machine learning data science people in the room? Cool, yeah. Do we have any like just developer type people? Cool. PMs, like program managers or business side? Cool. Basically, I was using different algorithms. I was looking at stop lists and feature sets. I ran experiment after experiment after experiment. So as much as like I make a bit of a joke about it, and there's a story behind it, there was some exciting research that was kind of happening in that space. But basically, to predict the outcome of the X factor, there was kind of two phases: create a sentiment analysis classifier based on domain-specific data. So sentiment analysis at the time wasn't kind of, I can just call an API and get the answer back, unfortunately. We are there now. That's absolutely possible. It's kind of a solved problem. But at the time, doing domain-specific data was really interesting because in the music industry or in the X Factor specific domain, the word music actually has positive connotations when you put it into a generic sentiment classifier. Well, this whole thing is about music, so that shouldn't wait, right? Because otherwise everything's going to be pushed up and be biased by positive. Obviously, this is the British public, and many, young people watch this. So, if you're down with the kids and people say sick or whatever the new thing is on the block, and it might not sound like a positive word, it might sound like a negative word to a normal sentiment classifier. So domain-specific data was very, very important. But I will be honest with you, so many people just say to me, like, well, did you predict the outcome of the X Factor or not? Like, that was basically like all of the people who came around to speak to me, like, well, did you predict it or not? And I was like, it's not really what it's about, but yes, it was actually okay. Interestingly, there's lots of skews in the data. When something's a competition, you obviously at the start of the competition have lots of contestants, so you don't have a lot of data about everyone, number one. But also ranking, obviously, on a much larger scale is a lot harder than when you start moving down to, 6, 5, 4 people in the competition. So I was able to rank correctly for the final 6 weeks of the competition. So when there were 6 contestants in the exact order of exactly what they got in the public vote. So that was quite cool, right? I was like, wow, maybe there is a connection between social media. Maybe we can really measure it. I was able to use support vector machines. So again, those in the data science sphere, hashtag old school machine learning. Like no one uses SVMs, support vector machines anymore. It's all about neural networks. You've probably heard of them. So this was quite a while ago, but when I was kind of looking back at it and I was thinking about how all of this stuff that I did that is all totally relevant still in text processing, I kind of said, you know what? One of the things I found most interesting about this research was the story behind a lot of this data. Because this data wasn't, the generic research data sets, COCO data set, MNIST data set, like predicting the outcome of, predicting house prices or something like that. Like, love to know what my house is worth, not super jazzed about it. Do you know what I mean? So this is exciting because I was like, actually, I'm the user. I'm the person that watches this stuff. So I really, really got into the data. And I found a few interesting things, and I want to share them with you. So number one, Twitter data has a natural bias. And it's actually, surprisingly enough for social media, it's actually positively biased. So I can't remember exactly what it was. And my supervisor said, oh, you need to go and like research what the biases are in the data. And I said, oh, it looks like in something like this, like a competition, it's actually hard to find a lot of negative data. People will tweet one way or post on social media one way or the other. They're either very, very excited, happy, jazzed about something, or they're not, and they're like the opposite, and they very, very much dislike something. You don't always get a lot of neutral, but sometimes, you know, you have the broadcasters who just like write like statements and stuff like that. So I split it into the three categories, but someone said to me, like, there's a really heavy bias in this data set that I'd mined, that was 70% like positive data, 30% negative data or something. And so for those in data science, when you do machine learning and the data sets are a bit like this, my negative class for classification was always not as good as my positive. Makes sense, right? There was more data, there was more examples in positive, and there wasn't as much for negative. So it would always most likely say it was positive, and then sometimes if it was very, very negative, it would go, yeah, it's negative. So one thing that I did, I said, well, if I'm using these data sets and I want, you know, my negative classifiers bringing my overall accuracy down sort of thing, I was like, well, what I can do is I could just try it with a 50-50 data set. So instead of doing sort of, well, you won't be able to bring it up because we can't just make up the data necessarily. You can, I guess you can sometimes, but kind of did this. So I brought down the positives. I thought, actually, try it with less data. It's not ideal because normally you want to use as much and variety of data as possible in machine learning. But I said, hey, like actually, if I can say, you know, the same amount of data in each class, positive and negative, could that influence? And then I also did a 60-40 split as well. So 60% positive data, 40% negative data. And the idea there was basically to say, okay, I recognize there is a natural bias and maybe I should be, you know, learning by that as well. Interestingly, the output was quite biased too. So got 4 different measures down here. NB stands for naive Bayes. That's a very sort of basic probabilistic algorithm. That was one of the ones I used. And SVM is a support vector machine, and that's one of the other algorithms. So there's these 2 algorithms. And then I measured for a 50-50 data set and a 60-40 data set. One thing to note, SVM always outperforms the other algorithm. SVM's great with text. The way that it's able to dissect like all the different data points, it's very, very well suited to a problem like this. So it always performed better. But something to note here is the 60-40 data sets always did better. So in both algorithms, so for example, the red line is 60-40 with the lesser algorithm, naive Bayes. And it is still, you know, 5% better than the other one, and the same with SVM. So the skew in the data set was quite intense. Do you know what I mean? But it was reflected in actually the outcome of the data. So for ethics in AI, I would love to say that we could just always have like completely balanced data sets, but we don't actually live in a balanced society, and we all know that, right? So one of the interesting things is, can we understand better our domains and our populations and kind of figure out and test widely what works best. So that's kind of point number 1. Point number 2, Ella. Ella Henderson was bookmakers' favourite to win. She was the one that everyone was like, oh my God, she's got such a great voice. You know, she's so nice, she doesn't know how good she is. Do you know what I mean? She had a bit of a confidence problem. And she would always top my rankings every week. She was very, very popular in the competition. Apart from one week, and it was the week that she went out, okay? And the week that she went out, we all know, right, what happens on these shows. Oh, X Factor's fixed, and the producers do it on purpose, and all that kind of stuff. And that was the headlines, the actual headlines in newspapers. You know, Ella's been brushed out of the competition, bookmakers, you know, lose or whatever, because there were so many people betting that she would be the one that would win it. It kind of felt like it was obvious almost. And all of a sudden, she just went absolutely ploughing out the competition. Everyone was very upset. Now, I thought, retrospectively, I thought, I'm going to dig into the data. I'm going to have a look, actually. So I took the week where all of a sudden she was really low down in my rankings. So she'd gone from pretty much 1 and 2 to like 8 and 9 or 5 and 6 or something. And so I pulled out the numbers. So the top one, she had 571 positive tweets, sweet, just in this like sample set that I'd got. But she had 2,500 negative tweets. Now, when I went out and I did some key phrase extraction, I was like, well, what's going on in here? It kind of said like, it's madness that Ella is at the bottom, and oh my God, Ella shock, like biggest shock in X Factor history that she left. And I was like, there's something wrong here. This was when X Factor got big, and X Factor was no longer just your Saturday night taken away from you, it was your Saturday and your Sunday night. So Sunday night was when that people left the competition, and Saturday night was when they sang. So what I did was I actually split out the Saturday and the Sunday data, because I said, hey, like the outrage at her leaving was polluting my data set. It didn't make any sense. So I took just the Saturday only show. And interestingly, she still had more negative tweets. She had 284 negative tweets and 232 positive tweets. And I was like, that's interesting, because normally she was very, very high up in positive tweets. And interestingly, I kind of dug in again. I looked at the key phrase. Now, this was a week that Ella must have picked a very popular song. Maybe it's like a Whitney song or something like that. And she like turned it into like a ballad. And so everyone was saying things like, God, you're boring, and like pick up the pace, and love the song, but she's ruined it type thing. So it's so interesting to see, actually, you know, as much as there was this like, this is an outrage that she left the competition, nobody liked her that week. Unfortunate, but if you don't like, you don't vote. And so it is so interesting to break down the data set, but also see that your assumption of just taking blocks of data and analysing them can sometimes head you down the wrong direction. 2,500 people, well, minus off that 200 tweets, 2,300 of them were outraged, but 280 of them absolutely agreed that she should have left. So when looking at data sets now, I'm always very, very conscious about pinning like what's actually happened, how is it laid out. So the Saturday, Sunday night thing, you would only know that if you watch the show, okay? And we all know, right, especially in data science, you're given all sorts of different problems. You can't always be a domain expert in them, but asking those questions of those domain experts is so important. I was lucky in this case, I was a domain expert. I was a big fan. Okay, Christopher Meloni. Don't remember Christopher Meloni? No, it's weird, isn't it? Whatever you do, don't Google his name. It is the disappointing side of the internet. Do you know what I mean? So we all know what it's like, right? Someone takes a small disliking to someone and the internet follows. And people are unfortunately very, very unkind when they hide behind a keyboard. And unfortunately, this happened to Christopher. So across the competition, he just had an excessive amount of negative tweets. Just huge. People just took a horrible disliking to him. He actually wasn't a bad singer. I did a lot of research for some of these talks, started looking back at YouTube videos. And one of the interesting things I found here was I was like, problem number one that we looked through was that I didn't have much negative data. Problem number three is I think Christopher fueled a lot of my negative data. So is my negative classifier just predicting Christopher's tweets? Or is it actually predicting negative sentiment? He's potentially got the majority percentage of that category. Is that balanced? Is that fair? Obviously, we had that 1 week with the outrage of Ella, but realistically, he might have fueled completely my negative classifier. So it's quite interesting, again, to just pick out one of these points where you're like, again, would people have known this? Not necessarily. I mean, I remember at the time seeing all the negative stuff, and he kind of like stayed in the competition for a little bit. The minute it went to the public vote, he was out. And the kind of side of it where you go, oh man, like this was really, really big within this data set. So again, I was absolutely obsessed with the data. Number 4, the final one. What does this mean? On the left is something called gold standard data. Gold standard data in machine learning tends to be the thing that you say, hey, like this is the correct data with the correct answers. And you kind of work with that as like your validation type thing to say, is my model good or not? And on the other side, we have Twitter. So we have our social media data. And one of the things I actually looked into towards the very end of my research, so I'll be honest, I didn't play on this one too much because I really didn't want them to mark me down. But I was a bit like, the gold standard data that I had was actually the public voting. So when you vote for the X Factor, now you can do it via an app and I think it's free. But at the time it was, you need to call up, so you've got to have a phone contract. You probably have to be the bill payer or ask whoever the bill payer is very nicely to if you can vote. And also, I think at the time, there was a lot of things saying they were actually struggling to get people to vote because people would just end up watching and not really contributing. But on the other side, Twitter is just anyone, right? Anyone who can set up an account, anyone who can actively share their opinions. So I was measuring the sentiment from Twitter, but the actual voting data could have been a very different type of person. So if I was to make a sweeping statement, the voting data might have been slightly older people with phone contracts who were willing to spend the money to vote, whereas Twitter could have been the younger generation voicing their opinions on exactly what they thought because it's free, right? Who buys stuff now? Like, I only use free-to-use apps. If they want me to pay, I'm like, no, thank you. So that's just like the bubble that we live in. So it was interesting to see, actually, my gold standard data was great at saying, hey, was my ranking very, very good? But I did reconsider afterwards, actually, like, what's going on here? So I was obsessed with the data. The data was the key. But realistically, in the area of AI and ethics, I'm going to say there's no silver bullet, unfortunately, at the moment. I was reading through stuff and listening to people speak, and I was like, well, you know, some people talk about, oh, can we just like change the parameters of our algorithm? And someone says, hey, like if you do this to your algorithm, it's not biased anymore. That would be lovely, right? Because that'd be a nice quick fix and everything would be fine. But I don't think we're going to get there anytime soon, number one, and I'm not sure this is just the only problem within here. The problem is much wider. So, quick question, would this be successful in the X Factor 2019? So this was 2012, so this was a good few years ago now. So I think it would do okay, right? Because it's positive and negative sentiment within the music industry. However, the interesting piece here is I had a chance to watch a lady named Kate Crawford speak at NIPS, which is a machine learning conference. And she did an amazing, amazing keynote where she said, classification is a product of its time. Number one, the X Factor has changed, just in the way that they do things, the way that they vote, the way, also the social media platforms we've used change. Many, many young people don't use Twitter. They don't, right? They use Instagram and they use Snapchat. And the interesting piece here is actually, would it work? Maybe it wouldn't. So it's always something to consider. Actually, machine learning algorithms have to be reconsidered. We have to update them over and over again. I then had a chance to speak to a lady at a conference, and she was from Turkey, and she said to me, Amy, love the talk, like, and we were chatting away, and she said, actually, in Turkish, we don't have gender pronouns. And I was interested because I said, oh, you should watch this keynote by Kate Crawford, she's wicked. And she said, yeah, no, we have this thing where classification is absolutely a product of its time because biases in language are very, very much from thousands and thousands of years ago. We have just been building up all of the biases. So the data we're actually learning from, for example, I did it, right? I put she as a developer in English, and I translated it to Turkish. If I translate it back, I was like, oh, no, you didn't, because that one obviously hurt there, do you know what I mean? He is a developer. Now, it's cool, right? I'm not saying, like, Turkey should be like, changing the way they don't have gender pronouns. But it's learnt from historical data, and probably in historical data, it more says he is a developer than it says she is a developer. Obviously, developer hits me here, but he is a nurse is exactly the same. That translates to she is a nurse. So we have these biases in society, and so as much as we want to do the right thing within tech, sometimes the data that we're using has bias in it from hundreds and hundreds of years ago. Interestingly, I was recording this, and I found this. So I went onto the actual website, and I was recording my demos, and I interestingly found a way that someone's worked around it. So she is a developer again, obviously, that one. Translate it to Turkish. Oh, what? Like, provide me with both. Good choice. Like, I almost sat there and applauded, do you know what I mean? I was like, actually, fair play. If the data is skewed, can we recognise that? And then can we build something in a different part of the product that helps us? So maybe there was feedback, complaints. Feedback is key, right? Whenever we're building something in tech, feedback is key. I am out of time, so I'm going to wrap up real quick. But one of my last points was diverse teams, not just in tech, but specifically when building AI projects, are absolutely key. There has been terrible examples of where people have unfortunately built AI technology and it has not had the chance to be diverse enough. Someone told me about a hand sanitizer machine that unfortunately didn't recognize darker colored skin. Like, what? Does a hand sanitizer machine, number one, even have to have computer vision? That seems like overkill to me. Do you know what I mean? But there should have been a diverse team testing this. There should have been testing early. So I wanted to give you my 3 takeaways from some of the people that I've spoken to. Number one is ask the question throughout the process and be obsessed with the data. I got obsessed with this data. It was crazy, right? I was just looking through things, trawling through things. We work with people of all skills and backgrounds to give us the chance to preempt bias. Now, I'm not saying that we can possibly have every diversity within an engineering team. You would have to have teams of thousands and thousands of people. Do you know what I mean? There's so many different cultures, there's so many different ages, so many different genders, there's so many different things, right, that we need to consider. However, the next one, if we are able to proof of concept early and test as widely as we can learn from our mistakes. A lady who works with Kate Crawford, actually, named Hannah Wallach at Microsoft. She works in our FATE organisation, fairness, accountability, transparency, and ethics. And she said this, and I was like, oh, but what about the brand? Do you know what I mean? Like, everyone gets axed if like something bad happens in technology and it's all over the place. She said to me, no, we shouldn't be bothered about that anymore. We should be open, and we should say, hey, like, I'm going to be honest with you, this is beta, like this is test. Can you test it for me? Can you help me? Can you help me test that this is going to be inclusive of everyone? So a few links, but that's all from me. The trouble with bias, that's the keynote. Please go to that link. It's the most incredible keynote I've ever seen. She absolutely smashed it. The FATE organisation, if you want to see a bit more about what we're doing at Microsoft about this kind of stuff. And if you want some actionable takeaways, go to the AI Now report. They're going to do one every year. It's in December, so the 2019 one will be in December. And they do a little summary. It's a huge document. But at the top, they'll give you 10 actionable items for this year, and they'll do it every single year, how we can potentially consider having better ethics in AI. Thank you for your time. I know I'm slightly over, so thank you very much. Yeah.